Welcome back. We will study composition and aggregation. Our example is called My Computer. Composition and aggregation are two methods that express certain relationships between classes. Let's start with the composition here. A composition means one container class is composed of several contents or parts, each is expressed in a class. So we can think of it as follows here. We have a container called computer with a part or a content called CPU here. A computer has a class of computer and the CPU has a class of CPU. So we have here our container class, the computer, with the init function here and the arguments, of course, self, processor, and cores. And let's have a pass for now. Let's have our content or part class, which is the CPU. So we have class, capital letter, CPU here, and let's have our colon. Inside the CPU class, let's define the constructor here, the init function. So we have init. And of course, we will have the arguments here, let's say processor and cores. And let's have our self.processor equals processor. And similarly, self.cores equal cores. Now, how can we tie this CPU to the computer? Let's inside the constructor of the container class computer, create the content object or the instance using the name of the content class here. So inside the constructor here, instead of this pass, we will write the instance self.cpu created from the CPU content class. And we pass the arguments of the content class here, processor and cores. This is composition. Since the content object self.cpu is created inside the constructor of the container class, it is related to the computer class. This is composition. Outside the classes here, we can start creating the object of the container class. So we have computer1 equals the computer class here. And let's have our attributes here. So we have processor equals, between quotations, say Intel, and cores equals, say 4 cores. Going back to the class computer, which is the container class, let's have a function here. So display computer, and let's have ourself here. What will this display computer function do? It will return using the f string, and between quotations, let's have the placeholder here, self.cpu, which is the instance created inside the constructor here, and which has the ability or the authority now to call any attribute or method from the CPU class, the content class. So let's have a dot processor. It calls the processor here, dot processor. Let's have here another placeholder for the cores. So let's have self.cpu. You must start by the instance inside the container constructor here, self.cpu, and through it we call the cores inside the content class. So we have here dot cores. Of course, we can write here a note that this is the content class. Let's have a print of the computer 1 now. So let's have print computer 1 dot the method here display computer. And let's have a run. It gives Intel and 4. The object computer 1 can call any method inside the container class, inside the computer class, and it calls display computer to execute this return and prints Intel, 4. We may even extend our example to include other content classes. So let's have here our container computer expressed through class computer here, having 3 contents or parts: CPU, mouse, keyboard. Each of them will have a separate class with a constructor. We already have the CPU. Let's have the keyboard. So let's copy this and have here the second content class, keyboard, with the language, which may be any language on the keyboard, English, Arabic, whatever. So we have here the argument language. And we have here, say, self.lang, abbreviation for language. And let's have here our language. And let's delete this, of course. We can have even a third content class, which is the mouse. A mouse can be wireless or using wires. So we have here the connection. And let's here have self.con for connection equals connection. Of course, here we must go back to the container class and add those arguments, which are the language and the connection. And let's have our instances here. The instance self.keyboard created from the content class keyboard. So we have a capital letter for the class keyboard here, with the argument, of course, the language. Similarly, we have another instance called self.mouse created from the content class mouse. So we have a mouse here. Of course, mouse here must be in a capital letter. So we have our mouse here with the argument connection. And let's extend the display computer here. So let's have another placeholder, comma, placeholder. Let's have this instance self.keyboard, which has the authority to call any attribute or method from the keyboard class here. So .lan. So we have here .lan. Let's have another placeholder for the mouse. Of course, we have instance self.mouse. Place it inside the placeholder and let it call the con for connection. Let's have computer 1 here, the object created outside the classes. And let's have our language equals, let's say, English. Have a comma here for our last attribute, which is the connection, equals, between quotations, say, wireless. This is our computer 1. It prints Intel for English and wireless. We can have another computer now. So let's have another object, computer 2. And let's have here computer 2. The processor is, say, AMD. Cores are 2. The language is, say, Arabic. And the connection is wire connected, say with wire. And let's print computer 2 now. We have all data for computer 2. So this is composition. We create the instance here inside the constructor of the container class using instance equals name of the content class with the arguments or the attributes. We can call the methods or attributes of any content class. So processor calls an attribute from the CPU content class, cores calls from the CPU class, LAN calls from the keyboard class here, and the con for connection here calls from the mouse class, .con. Outside all classes, we create the container object using the syntax of instance here equals the name of the container class with the attributes passed to the arguments. And of course, once this object is created, it has the authority to call any method inside the container class. Since the instance here is defined inside the constructor of the container class, it has the same lifetime of the container class. If the computer class is deleted, the instances here will never exist. So we can say that the container owns the contents or the parts, which cannot live without the container. Let's now go to the aggregation. We have the class computer, and all parts are just related to it. They are not part of it. This is the container class. So we have the constructor with self, CPU. So instead of this pass now, let's have self.cpu equals CPU. So we have self.cpu equals CPU. And let's have a part class now of CPU in capital letter. Let's have our colon here. And let's have the constructor for the CPU class. So let's define the init function. And let's pass here the arguments, processor and cores. Of course, we must have self.processor equal processor and self.cores equals cores. In aggregation, we create the parts independently outside the classes. So let's have here outside the classes our first part, CPU 1, which is owned by the class CPU. Our instance CPU now is created from the content class CPU. So we have here CPU with the attributes passed, say Intel or processor equals Intel between quotations. We can write Intel directly anyway. And let's have a comma here for cores equals, say, 4. This part here belongs to the content class. It is created independently outside the classes. And therefore, if the class computer decays or is deleted, it will not affect the CPU 1. It can survive without the computer. Going back to the computer class, let's have another function which defines the computer or displays the computer. Define a function called display computer. Of course, with the self here, what does this do? It returns using the f string between quotations and have a placeholder here. We have self.cpu, which is this instance here, and has the authority now to call any attribute or method. So it calls processor here. Similarly, having another placeholder here, we can have self.cpu. Here the same instance here created. Calling the attribute of cores. Let's create a computer object now. So we have computer1 equals the computer class that is created through the computer class, and we pass the instance CPU1 to it. This is aggregation. We aggregate the instance of the part class to the instance of the container class, CPU1. And let's have a print now of computer1. So print computer1 dot display computer here. It has the authority to call any method inside the container class. And let's have our run here. It prints Intel and 4. Of course, we can have more parts here. Let's have a note here. This is the container class. This is a part class. And we can have other part classes. So let's have a copy of this. Let's have a class of keyboard with the argument language. And let's have here self.lan equals language. And of course delete this. We can have another part class for the mouse. Let's have here the argument connection, whether wireless or having a wire. And let's have here con for connection. And let's have here equals connection. As we created CPU1, the instance from a part class CPU, we will create keyboard1, an instance from the part class keyboard, and mouse1, an instance from the part class mouse. So we have here keyboard1 equals created from the class keyboard. So we have here keyboard, and let's have here language equals say English. Also let's have mouse1 equals created from the class mouse here. So we have, yes, of course, mouse again here must be in a capital letter. So we have here mouse, the part class, and have between brackets our attribute here. So we have connection, equals, between quotations, say wireless. And we have computer1 here, the object or the instance concerning the container class. So we have computer, CPU1, comma, keyboard1, comma, and have the instance mouse1. For the display computer, let's adjust it here. So we must adjust it using the keyboard language and the mouse connection. But before doing this, we must add the attributes here, keyboard and mouse. And let's have our self dot keyboard equals keyboard. And let's have another self dot mouse equals mouse. Let's adjust the display computer function now, having another placeholder for self dot keyboard. Self dot keyboard now has the authority to call the dot len attribute here. So we have here dot len. And let's have another placeholder for the self.mouse, which is the instance here. Dot, and now it has the authority to call the attribute here, dot con, for connection. Let's have our run now. It gives intel for now the keyboard and the mouse are added. So this is really aggregation. The instances of the parts are created outside the classes. We inject those instances here of the parts inside the object of the container class using the syntax object equals container class open brackets and have the instances aggregated or injected in it. So having a quick comparison between composition and aggregation. So for a composition, parts are considered part of, while in aggregation, the container class has the parts. It doesn't own them as in composition. Going back to composition, we create the instance inside the constructor of the container class using the instance, of course, of the part class equals the name of the content class. Between brackets, we add the arguments or the attributes. This is really composition. In aggregation, the parts are created independently outside the classes here, outside the class, using the syntax instance equals the name of the content class with the attributes. Those attributes are consequently passed to the arguments of the content class. We then inject or aggregate those parts into the container using the object of the container equals the container class with the instances of the parts created outside here. This is aggregation. Going back to composition, the object of the container class is created, of course, outside the class. And we can call all methods or attributes of the container class using instance.attribute or function of the container class. Now let's have the true comparison here. Concerning the creation, the composition, the content or part instances are created inside the constructor of the container class, while in aggregation, the instances of the content or part classes are created outside the classes. They are then passed inside the constructor of the container class using self.instance of part equals instance of part. Concerning the ownership of parts, the container owns the contents. Here the container does not own the contents. Concerning the life dependency, parts or contents cannot live without the container, of course, because they are created inside the constructor of the container. Parts can live independently in the aggregation and can be shared or reused because they were created outside the classes. This concludes with our first example on composition and aggregation.